Hello, my name is Quentin Groom. I work at Miser Botanic Garden in Belgium, and I'm going to talk to you about the TRIAS project, which is about the rapid mobilization of data to improve decision making on invasive species. We often think of data workflows in a linear fashion, but in TRIAS we try and think of it much more cyclically. Data on biodiversity comes from many different people, from scientists, from ecologists, but also a very large number of volunteers, so-called citizen scientists. And we're also joined by decision makers who dictate policy, but also support us in our work. Out of this community, we have checklist data, but also observational data in large volumes. And those data can be used to create dynamic indicators of biodiversity change and to create checklists as well for the whole country. For invasive species work, we need risk models, and we can map risks on the country, and we can use those data to create risk assessments to decide on priorities and policies. And all of this needs to be published to feedback not just to the decision makers, but all the people who provided the data to. We see this as a very important motivational factor. There's nothing worse than providing data to a system where the data just seems to disappear down a black hole, never to be seen again. And so providing outputs suitable for volunteers and scientists and decision makers is important. The TRIAS workflow looks a bit like this. We get occurrence data from many different sources. We go to experts in particular taxonomic groups and get checklists from them, and we publish these all to GBIF as fair open data. We then harvest from GBIF, and we do this because not only do we want to pick up all the data we supply to GBIF, but we want to pick up all the data other people may have supplied to GBIF, and then we can aggregate all these data. So the checklist data can get aggregated into a list of introduced and invasive species for Belgium, and this can be given to GRIFS, the Global Register of Introduced and Invasive Species. The observation data can be aggregated into a data cube, and out of this we can get indicators, maps and models out. So this is one example of a data publication workflow, particularly for checklists. We get data coming in all sorts of different formats. These might be spreadsheets, they might be Word documents, they may be just on paper. The first up is making them digital into tidy data, as described by Hadley Wickens. And then we use a bespoke mapping script to map these all to Darwin core. This makes all the data interoperable, but it's not fair data unless it has metadata. And we do this in the GBIF IPT tool, and then publish it to GBIF. So this is just one example of one particular data set, and every single data set is published individually so that it can have a life of its own and be cited individually. This gives credit to the authors of those particular data. It has a DOI so that you can cite it. It has a license so that you know that you're allowed to use the data. You can download the data from each checklist individually, or you can use the GBIF API to pick up the data using machines. And of course it has the full range of metadata, the temporal, geographic and taxonomic scope, but also all the methods and bibliography that's associated with the checklist. In the process of doing this, we found that Darwin core is limited for certain fields, particularly related to invasive species. And instead of just ignoring this, we have actually created proposals for getting Darwin core changed, and we've given those proposals to the Biodiversity Information Standards Organization, and these will soon go into public review. So the Darwin core term establishment means already exists, but we've made recommendations to update its vocabulary to say whether things are native or not native to a particular area. The Darwin core pathway term does exist, but is in an extension of Darwin core, and we are recommending that it goes into the core of Darwin core, and we've also suggested a vocabulary for that. We have also recommended creating a new term called degree of establishment that allows people to say how well established an organism was when they observed it. For instance, they might know it was a vagrant bird or wasn't going to last very long at that particular time, and we've suggested a vocabulary for that as well. So I recommend, or I ask you to go along when you see these, go to public review and support them or comment. So if you followed the work of GeoBon for any length of time, you will have come across data cubes. These are cubes of data with the dimensions of time, space, and taxonomy. Although you may have heard a lot of talk about them, you won't have heard of many people actually making them because it's not that easy. When you get data from GBIF, you get it with a point and a coordinate uncertainty in meters. And if you look at the left-hand map, you can see a point with a coordinate uncertainty that fits very well into a grid cell. But the other two maps show that many observations don't fit very well into grid cells. You could just throw away all of these observations, but that would leave you with very few grid cells actually occupied. And so you have to think of ways that you can decide on which grid cell should actually be allocated. In our case, we've done it randomly within the circle, based on the proportion of that circle within the different grid cells. This is what our data cube actually looks like. It's actually two-dimensional. On the left-hand side, you have the year, then you have the grid cell code, then you have the species key, which comes from the GBIF taxonomic backbone, which has helped align all our taxonomy from all the different data sets. And on the right hand side, you have the number of observations that contribute to that one occupancy, and you have the minimum coordinate uncertainty that was used for that occupancy as well. Down the bottom, you can see there's a occupancy with 51 observations and a minimum coordinate uncertainty of 10 meters. So we're highly confident that that one particular occupancy is correct. But you can see other occupancies that come with very little data or a very high uncertainty. And it's really up to the users of the Occurrence Cube to decide what data they want to include and which ones they think are too uncertain to include. Once you have your data cube, you can create trends from that. In this particular case, we are looking for emerging species in Belgium, species that we may not have recognized that are actually increasing rapidly and that we might want to do something about and put management actions into place. In this particular case, we have a well-established species, Impatiens glandulifera. On the top, you have graphs of occupancy. On the bottom, you have graphs of observations. And it's all been fitted with a generalized additive model to smooth the curves, and the colors give you some idea of whether the species is emerging or not. On the right-hand side, the two graphs are being corrected to some extent for recorder effort. We can also create models. So this is a model using current climatic conditions for Impatiens glandulifera. As you can see, the risk of it occurring anywhere in Belgium is very high. But we can also look at the confidence we have in that prediction. As you can see, we have fairly high confidence in that in central Belgium, particularly in the north, but much less confidence in the south and east of the country. And that's at least partially because many more people live in the north. We get many more observations coming in from the north than the south. And so that's partially why that's the case. But this can be used to evaluate the value of the predictions. We can also look at climate change scenarios. So this is looking at one particular climate change scenario in 20 to 50 years. And as you can see, the risk predicted is actually considerably lower than it is currently in the north, but it's perhaps increasing in the south and the east. So we think we've achieved creating our full cycle, although we have some work to do on the publication side of things. This workflow is completely open, all the code is open, all the data are fair open data. It's dynamic, you can add another checklist and rerun it all, you can add new occurrences as they come in. It's rapid. We could probably finish all this off in a week if we really rushed, but probably 2 weeks is more realistic. It's reproducible. You can take all these data and the code and do it yourself, but it's also reusable. You can repurpose all of this to use it for a different country, for example. This is the Trias team when we started. We're all a bit older and grayer now. Thank you for your attention. I'm very looking forward to hearing your questions.